Hello all. Now in this lecture I am going to teach you how to solve problems based on three-phase star and delta connection networks like three-phase induction motor or three-phase synchronous generator, those things. So always we used to get the confusion that when to find the phase voltage, when to find the line voltage and those things. Okay. So here first we all should understood one point, that what is phase and what is line. Okay. So first, phase means simply a wire. So three phase means three wires. To identify the name of the phase, so one we call it as a red color and another one we use yellow color and another one we use blue color, RYB. R phase, Y phase, B phase, generally we call it. So here this RYB phases means it is simply a wire. Already in some other video I have explained all the three phases carries same magnitude of voltage and same magnitude of current, both are same. Then what is the difference? So the difference is, if the VR phase, the R phase is having the voltage VR here, and then the Y phase will be, the voltage of Y phase will be 120 degree apart. Okay, the difference between each phases are 120 degree. Here 120 degree and here 120 degree. This is called phase. Now, so when we call it as a phase voltage, what do you mean by phase voltage? So phase voltage means, if I have one wire, one phase, it can be R phase, it can be Y phase, or it can be a B phase. So if we measure a voltage which is between, so if this can be R phase, or this can be Y phase, or this can be a B phase, and we can have a neutral wire. Okay, so neutral wire means it is used for the return path. Okay, it does not carries any voltage. So if we measure a voltage between one phase, it can be any phase, R phase, Y phase, B phase, between one phase to neutral, if we find the voltage, that voltage is called phase voltage. Okay, so that voltage we call it as a phase voltage. So phase voltage means always one phase to neutral, otherwise one line voltage to neutral, line to one line, this is one line, one phase. Okay, so the phase voltage means it is between one phase and one is neutral, between this. Okay, and now what is a line voltage? Same way, phase current, what do you mean by phase current? Means the current which is flowing in this particular wire. Okay, in this particular wire, whatever the current is flowing, that can be called as the IR, mean R phase current. If we take this one as a Y phase, then it will be IY. If it is a B phase, then it will be a IB current. Okay, so first one is the phase voltage and phase current. Phase voltage means voltage between one phase to another neutral, and the current flowing in that particular phase is called a phase current. Okay, so here IP is the current flowing in that particular phase. Okay, particular phase. Okay, now this is clear. The next one we move to, what is line voltage and line current. Okay, so the line voltage, line current means, suppose if we have three phase and these three phases are connected in star connection. So now we can give the name, so we can have a clockwise direction. Starting from here, if this is R, the next one will be Y and next one will be B. So this is R, Y, B phases are there. Okay, so here what we call it as, this is only R phase. Okay, and this is the Y phase and this is B phase. Okay, so this is the end terminal, this is end terminal, this is end terminal. Okay, now here when all the phases are meeting at one point, we call this one as the neutral. So when we have this neutral point, what is line voltage means? The voltage across one phase to another phase. See here, what do you mean by voltage? Voltage mean potential difference. Potential difference between 2 points. So you can have potential difference between these 2 points. Same way we can have potential difference between these 2 points as well. But here the difference is, it is the potential difference between one phase to one neutral, but here the potential difference is one phase to another phase. Okay, line to line. Okay, if we consider this is a line, this is a line, so it is a line to line voltage. So how here we can call it as it is a line voltage. Okay, so what is line voltage? Line voltage means voltage between two phases. Okay, two phases are line to line, phase to phase. Okay, the next one, what is called line current? Okay, so the line current is here this is only the phases. After the phase whatever is coming out, we can call it as a line current. Okay, so this can be the line current. So here it suppose this is R phase, so IR will be there. If this is the current is going here, this also can be IR. Okay, so in this case we can say the phase current and line current both are same. So you can just to understand the concept, simply you can assume it like this. This is the phase, this is only the phase, so the current flowing in this particular region you can call it as a phase current. After that, whatever is coming here, you can consider it as a line current. Okay, so what is line current? That is outside of the phase, whatever the current is flowing, that can be considered as a line current. Okay, so now we are very clear what is phase voltage, what is phase current, what is line voltage, what is line current. So phase voltage is the voltage between phase and neutral. Phase current means the current flowing in that particular phase. Then the line voltage means the voltage between two phases, and the line current means the current which is flowing after the phase, whatever the line is available in that place, where whatever is flowing, that is a line current. Okay, now so in this particular case we have to see each star separately, delta separately, how to deal with it and how to find out different equations, how to find out the relations. Okay, so here we are seeing here star connection is there. Okay, so in the star connection, here this is a neutral. Okay, so if we take this as a neutral, here see here what is the voltage across this position. So let us take this direction. So in this direction the voltage will be VRN, and here in this direction the voltage will be VYN, and in this direction the voltage will be VBN. Okay, so all are going inside. Suppose if you take this opposite direction, suppose if it is opposite direction, now this time you can take the voltage as VNR because it is starting from N. Then this can be written as VNY, and this is VNB. Okay, so when the direction changes, you can write this is R. So what is this one? This is a phase voltage. So if any star connection is given, if you want to find out what is a phase voltage, this is how you have to find out. Okay, so one phase to another neutral, what is the voltage? So either you take this direction or this direction, simply you are going to change the terminal. Okay, this is the phase voltage we have taken, that's all. Okay, now the next point is that how to find out the current. Okay, so in place, if for current purpose, see here, this is a star connection. In the star connection, if we assume here some current is flowing in this direction. Okay, if this current is flowing in this direction, let's say it is IR. Now this is the phase is over. Now when coming out this side also, when it is coming here, this is line, so here also the same current, because it is series. See here, it is in series, so same current is flowing. So here what we find from the diagram itself, one point is very clear: in star connection the phase voltage is equal to line current. Sorry, here phase, not phase voltage, phase current. Phase current is equal to line current. One point there is no need of any phasor diagram, any explanation, anything. Simply it is just visible here. Okay, it is direct. So one relation we got it for star connection. For phase current is equal to line current. Okay, and we also identify this is a phase voltage available. Okay, Now the next point is that here the relation is over. Line voltage is line current is over, phase current is over. That's all. This is the line current and phase current. That's all. It's over. But now coming to voltage, what is the problem here? It is very clear. If I consider the R phase, okay, if I consider this R phase, the voltage across phase, that is the voltage across this one, that is VRN, okay, that voltage is not equal to this one, voltage across this one, VBR, okay, VRY, that is VRY, between this one, this is R phase, this is Y phase, so VRY. So it is very obvious that VRN is not equal to VRY, where what is VRN? It is a phase voltage, and we know what is line voltage. Line voltage means one phase to another phase. So this is R phase to Y phase. So if we are having RYB between these two and between these two, so what are the line voltages? VRY, VYB and VBR. So these all line voltages. So here these phase voltages and this line voltages are not equal. Okay, line current, phase current are equal, but line voltage, phase voltage, both are not equal. When it is not equal, then what is our duty? We have to find out the relation. So what is the relation between them? Okay, so the next point we are going to find out the relation. How to find out that? Okay, now for that we have a phasor diagram, and before the phasor diagram, let us assume in another physical point, what to call, practically let us understand how the star connection, how this phase voltage, this line voltages are different. Okay, now if you consider this one as a motor, okay, now let us consider this as a motor. So this motor has R, Y, B terminal. Okay, when you buy a motor, so what you have to do? You have to give the supply. If even suppose a mixer grinder, if you are having that mixer grinder, you are inserting the plug, so it means you are giving a supply. If it is a single phase, you give a single phase supply. If it is a three phase, you give a three phase supply. So if it is a motor, we are applying the supply. So in this time, this first line current will flow here, IR, here IY, and here IB will flow. And before that, what you are applying, which voltage you are applying? You are applying here, here, here. Okay, so it means you are applying a line voltage. You never apply a phase voltage. So you apply VRY here, and here you apply VYB, and between this you apply VBR. Okay, now you have applied the line voltage and it is flowing now. Line current is also flowing, but this is here only the motor is there, three-phase motor is there. How it is going to take the voltage which you have applied to it? How it will take? This particular phase will create here neutral already, because it is meeting at one point. So whatever you have applied here, this one, it is not going VRY directly like this. So somewhere it is dividing, and some portion is going here and some portion is coming here. Okay, it is vice versa. So this is what we have to understand. So what you apply is a line voltage, but what the motor particular phase have taken, that is a phase voltage. Okay, so in this particular case, if we consider it as a so here, see here, so line volt, here the current which flowing is also same, both here you applied line current, the same current is flowing in the phase also, but whatever you applied here as a line voltage, that is not equal to the phase voltage, that is not equal to the phase voltage. Okay, so here what we understand, the line voltage, phase voltages are different. In case this is the case of motor we have taken. Now let us assume if the same case, if it is generator, what will happen? Same R phase, Y phase, B phase is there. Okay, now this is also having a terminal point, that is RYB. Okay, now this is a generator. For generator, you no need to give any supply, electrical supply. It will generate the electrical supply and it will give it to the load. So here you can connect it to the load. Okay, load means what? You may connect any ceiling fan, any fan or any induction motor or anything you can connect. So here you are connecting a load. Okay, so now what will happen? It is a generator. So whenever the armature rotates, it cuts the EMF and EMF is generated. Now that EMF, that voltage is only we are going to take it in the load. So here this is a neutral. Now in every phase the voltage will be induced, EMF will be induced. Since it is induced in this particular phase, so this will be a phase voltage, and here this will be Vy and this will be Vb. Okay, in every winding, every phase the EMF is induced. So that is phase voltage is induced. Now once it is induced, since you are connecting a load, since the circuit is closed, now what will happen? From each phase the current will flow outside. See, in case of motor the current was flowing inside, but here the current is flowing outside. So see here, so IR will come here, then this is a line voltage, it's a line current, then IR, here IY and here IB. Now when you are taking outside, when you are giving to the load, it is not going as a phase voltage, it is going as a line voltage, because you are giving between RYB, between RY, YB and BR. So it is going as a line voltage. Okay, so this is what, how it goes inside, how it comes outside. So if you understand this concept, it is very easy to solve anything. Okay, suppose whenever in any numerical, suppose if they give 440 volt induction motor, so that 440 is a line voltage or phase voltage? Yes, it is line voltage. The reason we apply between RYB, we don't apply between RN, YN, BN like that. We between RYB, we apply between RYB. Always we give a supply to that is line voltage only. So whenever it is written like that, it is a line voltage obviously. When we are talking about this generator is supplying load is the load voltage of 440 volt means, so it is supplying a line voltage only. Okay, unless they write specifically it is a phase, otherwise it is line. They are talking about especially about the line voltage only. Now one confusion will be there. Then when I have to find out a phase voltage, so why can't I use directly the line voltage in the calculation? Why I have to convert? So for that purpose, now let us talk about simple thing. Now I have a star connection. Okay, now we have a three phase. We know this is a winding. Each winding will have a resistance, and here it will have a resistance, and here also it will have a resistance. Now if I want to find out what is the current here, okay, if I want to find out what is current in this particular phase, so how do I find out current? So I find the current I equal to V by R. If I want to find out current in R phase, so I consider only the voltage in the R phase. So if I apply here VRY, if here I know only line voltage, but I am finding current in this particular phase, so I can't consider the voltage between these two phases. Okay, the VRY is connected here also, it is consist of this wire also. So this RY, this line voltage, I can't consider for finding current in this only this wire. So that's the reason if I want to find out phase voltage of this phase, then if I know the line voltage, first I have to convert this line voltage to phase voltage, then only I can apply here. Then if I find the current, only that current says the current in this particular phase. Okay, so it is vice versa. In case of delta connection also it is same. Now we talk about delta connection. Okay, so if it is delta, what is here? Here R phase, here Y phase, and this is B phase. Now when we talk about this, see here, this is R phase. From here to here R phase, from here to here Y phase, from here to here it is B phase, and here this is line. Okay, if this is line, suppose if you assume this is a motor, okay, so we apply line voltage. See here VRY, here VYB, and here VBR. We apply line voltage. Now see here, you apply line voltage here between this. Okay, so this Y is here you apply line voltage, and this is one particular phase. So the complete line voltage is going to this particular phase. See here, we are applying the voltage, line voltage. Okay, here we apply line voltage between this, and this is going one point here and one point is here. So ultimately it is applying here. Okay, and whatever voltage we apply from here to here, it is directly connecting here. Okay, so it means here it is very obvious that in star connection, in delta connection, whatever the voltage here we apply, okay, this voltage exactly same to voltage across this line. This voltage is same as what is we apply here, and here this voltage is same as what is voltage applied here. So here we get the line voltage and phase voltage both are same. Okay, now when we talk about the current, so let's say here we have a current IR is flowing, that is line current, and when this IR is flowing at this particular point, it start divide. Okay, so this is called the line current, and when it goes inside to the phase, it is not same, so it is dividing. So we got the point that the line current and phase current both are not equal, so it is opposite. Like a star connection, here delta connection, it is different. There the voltages are different and here the currents are different. Okay, so but the relation is same. The relation same, what is the relation between voltage in case of star, the same answer we will get it in case of delta as well. Okay, so we know that both in star and delta, either voltage is not equal or current is not equal. So we have to find out the relation between among them. So how to find out? So now here you can see the phasor diagram mentioned here. We have three. First we have to draw this is for the star connection. Okay, so here we are seeing this is for star connection. This is for star connection. Okay, so in star connection, to get the relation, first let us draw the voltage. Like first one, here when we take, this is Rn. Okay, and here we take, this is Yn, and this is Bn. Okay, so here let's say we take Vrn, Vyn, and here Vbn. Okay, so now we want to find out line voltage. See here, this is line voltage. So what is line voltage? Vry. Between Rn and Yn we get a line voltage Vrn. So how to find out? This voltage, resultant is Vrn, because these two phases are resultant is Vrn. So first one we take. So actually what is Vry? Here let me draw it clearly. So here, okay, so here the line voltage we apply is Vry. Okay, because this is R, and this is Y. But here the voltage is here to here is Rn. And see here, what is Vry? This is the complete circuit. Start from R and ends at Y. So what is Vry? So Vry is equal to Vrn plus, from N only Vrn end here, then here only it starts. So Ny, not Yn. So it is Vny. So we have to find out Vry, which is equal to Vrn plus Vny. So here we have Vrn and here we have Vyn, but actually what is there? Vny. This Yn should be changed to Ny. So you simply directly draw this opposite, then it becomes Vny. Okay, now you take a resultant. So what is the resultant you will get? It is simply, this is one vector, this is another vector. When you find out the resultant, what answer you will get? So we actually, from phase voltage, we are finding the line voltage. So what will be the answer of line voltage? It will be √3 times phase voltage. This is the relation we get. Okay, we can find out R, YB, VRY, VYB, VBR, all will be the same. So here this it shows all the three phases only. So when we look at it, you can see it very clearly. So let me zoom this particular phasor diagram, then I will show you, then you can understand very easily. Okay, so the relation is root 3, line voltage is equal to root 3 times of phase voltage. Same thing we will be drawing for delta, but replace the phase voltage into phase current, then you will get a relation of line current, and line current will be same formula like this. So here line current equal to root 3 times of phase current, that's it. Okay, so now let I zoom this and show to you. So I'm not able to zoom it. See here, VRN. So here it is VRN, and then here VYN, and here VBN. So angle difference is 120 degree. So we want to find out VRY, where VRY is VRN and VNY, not YN. So this we are taking it opposite direction. After taking opposite direction, we find the VRY, and this resultant you will get the answer of root 3 times of phase voltage. Okay, so what we do, how we do, so root of, see here, this one will be VRN, okay, VRN the whole square plus VNY the whole square plus 2 times this voltage. So since all are different, but all are phase voltage, the magnitude is same. So simply you will be replacing this voltage by Vp square plus again Vp square and plus then 2 Vp. What is Vp? Phase voltage. And then again. So when you find out, so here you will be having, first you will be writing VRY. And finally what is VRY? Finally you will change the VRY into line voltage. It is obviously it is line voltage. Then you will get the relation root 3 times of phase voltage. So this is how we do it for the star connection as well. Okay. Now coming to the next one is how to find out the power. Okay. Now the question of how to find out power, which voltage I should use. Okay. Very simple. First of all, what is the formula for power? For in case of AC, it is VI cos phi. Okay, power. But this VI cos phi is when you have only one phase. So in this phase the power is this one. But if you have three phases, what will be the power? What will be the power? So power P equal to, now if for this phase this is a power means, so this will be phase voltage and this will be the phase current, that's all. But same way you have a three phase, every phase have a phase voltage, every phase have a phase current and cos phi. So if you are having a three phase, you simply multiply by 3 Vp Ip cos phi. Okay, whether it is a star connection or delta connection, so the power is 3 Vp Ip cos phi, phase voltage, phase current, cos phi. But how to write in terms of line voltage, line current? It is again very simple. How? So we know the formula, it is 3 phase VI phase. Now suppose if I want to write for star, how do I write? We know in star connection the phase current and line current both are same, but we know that phase or line voltage is equal to root 3 times of phase voltage. Okay, now so same power let me write in terms of line. So here 3, here 3, here the phase voltage, so the phase voltage will be line by root 3. Okay, so VL by root 3. Now phase voltage and line current both are same, so IPH can be written as IL and then cos phi. So now this 3 can be written as 2 times root 3 and 1 root 3 will be cancelled. So what is P? P equal to root 3 VL IL cos phi. Okay, so in terms of power, if you are finding a, in terms of phase voltage, phase current, if you are finding a power, it is 3 Vp Ip cos phi. But in terms of line voltage and line current, if you are finding, it is root 3 VL IL cos phi. Let us think for the star delta connection. What is the formula in here? It's come. Okay, for delta connection. So again the power. What is the power? P equal to 3 Vp Ip cos phi. Now for delta connection, we know line current is equal to root 3 times of phase current, but the line voltage equal to phase voltage. So P equal to 3 same, but now V phase will be written here. V phase and VL both are same, so V phase directly can be written as VL, and here IP equal to IL by root 3, so it can be IL by root 3 and then cos phi. So here this can be written as root 3 and root 3. So here you cancel it. So what is the answer? Root 3 VL IL cos phi. Okay. So there should not be any confusion when we solve numerical based on 3-phase star and delta connection, and when to convert that phase voltage into line voltage and line voltage into phase currents, whatever the combinations. Okay. And I hope it clears all your doubts regarding this 3-phase star and delta connections, and when to find out and how, what is the power, everything. So if you like it, please share and subscribe. Thank you.